Yeah, let's wait for 2 minutes to join all the students. Meanwhile, I will share the screen. Yeah, yeah, we can start the session then. There are maybe many new students here, so that I will introduce myself again. I'm Swapnil Mane. I'm doing PhD at CSC IIT Jodhpur. I'm working in a group of social network analysis and applications group, which is affiliated to CSC department. My primary area of research is in social network analysis and natural language processing. Okay. Yeah, let's start the session. Let's move to the questions. So in this session, this is a week 5 live interactive session. In this section, we are primarily discussing questions uh, about the structural balance, how we can structural balance network, and when we can call a network as a structural balance, right? So for that, we are taking as in positive age and negative age, which is a friendship age and negative age. Another concept we have also studied in this week, which is about the uh, locality segregation, right? Based on the scaling method, we will do we will segregate the uh, or we will balance the network. How we can segregate the network, which is, and suppose that person is and found their neighbors is and similar, they are similar type beyond the threshold, then we'll stick that to particular location. If the threshold is not matched or not satisfied that condition, which is and less than the threshold, has an similar type of neighbors as there, then in that case it will be moved to the another position. So it will be implemented by using the scaling method, which is has been applied on that. So that those algorithms already discussed and implemented in this week lectures. Okay. Okay, let's move to the questions that cover these concepts, right? The holistic perspective of these questions, these concepts we are discussing here. In between, if you have any doubts, please let me know. Okay. Yeah. So let's move to the first question, which is about the select all the triangles that are stable. So there are four options has been given to you, which is an A, B, C, D. So in A, you can see here all there is an triangles or triadic graph has been given in each option. So we have to evaluate that the each triadic is an balance stable or not stable, right? The based on the his relationship, the friendship and the enmity, that is in, suppose it is an positive age is there, then there is an friendship in between them, right? Close friendship in between, the positive friendship in between them. And if it is there is a negative age in between, a negative sign over the age in between the users are there, in that case we are calling as an they are enemy to each other, right? So the here we can consider as an A, B, C. These are the those are the users. So we have to evaluate it, which is an A, B, C. They are structurally balanced or not. Okay. So in here, the first option is that the A, B, C. Those are the friendship to each other. There is a no as such enmity in between them. So all the friendship is in between them. There is a no issue. So in this case, in this scenario, we are calling as an this is a stable network, right? This is a stable network. Let me take a pen. Let's one second. Yeah, sorry for the disturbance. So let's consider the second option, which is an the triadic example has been given, and in that triadic example there is an only one friendship it is there, and there is an for the A and B there is a common enemy for those user, which is an C. So let's recall that one example has been covered in this week lectures, which is and there is an two employees are there, and over those two employees there is one common boss is there, and those that boss is a bullying to those employees, right? So they are discussing about that boss about that bullying, and so there has been after some period of time there has been a stronger, or we can say a friendship has been built in between those users, and there is an negative age, which is an enmity ages has been drawn to that boss, you can see here. So here let's assume that this is an employee E1 and employee E2, this is an boss B1. Let's take an one example. So this is an balanced so we can say as a, sorry stable structure, we can say that, okay. So this one is a stable structure, and this one is also. Let's move to the option C. In that, you can see there is an three users has been given in that triadic structure. The all the relationship between in between them, which is has an negative relationship, which is an enemy in between them. So this is not possible, as actually discussed in the lecture, which has been means suppose there is and two negative edge there at most, or at least there is an and there is been or must be a positive relation in between uh, the user. So let's take an example, which is, and suppose C is there, and there is an two edge outgoing from this C nodes, and there is an A and B is there, right? And there is a negative edge in between those A to C and B to C also. So there is a must age will be inserted or will be developed after some period of time, which is, and positive relationship will be inserted after some period of time, which is, and which shows, and there has been friendship has been made after some period of time because of the common enemy, okay. Yeah. So so this practically this is not possible, right? One sec. One sec. One sec. Yeah. Okay. Sorry for the inconvenience, because there is an some issue over the video. Okay. Uh, yeah, this option is also unstable actually. The C option. Yeah. Then let's move to the last option, which is, and the triadic structure has been given in that there is an two positive connections are there and negative connections. Let's recall one example as an uh, there is, and one boy is there, and in that particular boy there is, and two relatives are there, one male uncle and aunt is there, and they are not talking to each other, and but so let's take, and this is an uncle note, and this is an aunt note, right? So, and this is an one boy, and there is an positive relation in between the uncle and boy, and aunt and boys there is an also positive relationship, which is an friendship network, friendship ages are there, but there is, and they are not talking to each other, uncle and aunt. So there is a negative age in between them. So that same example I'm considering here, which has been covered in the lecture actually, okay. So uncle is saying to let's go to the party, and let's have a enjoy, right? Let's make a enjoy this Saturday Sunday, and auntie is saying let's go to the one temple, and we'll make their we'll take some the we'll take some prasad and all the things, we will roam around that place, right? And so they're proposing multiple options, and so he uncle has given the options, if you want to go with me, so there is no you should not include the uncle, aunt, right? And aunt is also given the one condition, so if you are coming with me, you should not include the uncle, right? So there is an loophole. So after some time, boys has decided, I'm not going to anyone with you, right? So this is a real life example I'm trying to align with this example, or that already example explained in the lecture as well. Okay, so this positive relation will not be persist, right? So it will made a negative, or this may goes after some period of time as an positive, that will be, well, then this is an stable, right? But if we are putting a negative age in between this uncle and aunt, and then we are evaluating this network is unstable or not stable, which is an unstable, right? So this situation can't be persist, right? No. Yeah. Yeah, so here the options are one and A and B options are correct here. Okay, so let's move to the question two, which is an which of the following figure represents a unsatisfied central node according to the scaling model of spatial segregation, given this threshold t is equal to 4. So, as we have seen that the scaling method has been used for the spatial segregation. Spatial segregation means the similar type of the users or nodes are coming together, right? And how many they are coming together? Suppose I'm that one node. Suppose let's take an this node, right? This node, so this node will check that his neighbor, if their neighbors is an similar type of his similar type, then he will stick there. If they are not similar types, then he will move to the another location. At that location might be he got an yeah, his similar type of neighbors, right? So here for so in this scenario, how you might be have a one question, that how much similar we wants to consider here, how much similar that node will be considered his neighbors, right? Similar types. Okay, so here you can see that threshold has been given, which is and t is equal to 4, right? So here the four figures has been given. So in each figure we have to evaluate for the central node, either each central node has been satisfied this condition or not. Okay, so you can see, so this green one, so he has an let's count the his neighbor similar type neighboring nodes, the 1 2 3 4, right? So this option A, the similar node has been satisfied the condition which has been given here, t is equal to 4, right? The second option, let's look at the central node, because in the question has been mentioned that we need to evaluate or check that that central node isn't uh, satisfied or not satisfied, right? It is central, right? Right. So in this question, this is a central node. Let's evaluate the how many similar type of neighboring nodes are there. This 1 2 3, only 3 are there. Here are the 4. Let's take another example. So I have not written the correctly 3. So here the 3. Okay. Uh, let's move to the another. So in this central node, so which one? How many neighboring nodes? 1 2 3 4. Sorry, 4. So here is also 4 is satisfied. In this, the red node is in the center. So let's count the red node, how many? 1 2 3 and 4. So yeah, so you can see here the this is correct, this is also, this option is correct, and this option is, only this option is not satisfied, because you can see here the neighboring nodes has not has been given the threshold value, right? It's equal to or greater than the threshold value, which is n t is equal to 4, right? Yeah, I hope you understood the question. If you have any doubts in this, please let me know. Is there any doubts in this question? Yes, anyone? If not, please we can move to another question. Yeah. So the question three, which is and in a 2D grid with a dimension 120 by this is an 120 into 90. Yeah. What is the maximum number of nodes? Maximum number of nodes that can have exactly eight neighbors. So how you can imagine this grid 120 to 90. Let's take an the simple example. Simple. Let's take an mm, um, sorry the 6 into 5, 6 into 5. So the 6 into 5. Okay. So you can see 1, 2, 3, 4. So like this way, the grids are there. How many cells? 6 into 5. Uh, so the 30 cells are there. So likewise, the grids has been created actually. So might be you have understood in the lecture as well, because that is an very nicely visualized the over structural nodes of the network actually. Okay. Yeah. So likewise, the grid has been created, and we have to find out that how many grids will require maximum number of nodes that can have exactly neighbors. Means so this is a one abstract calculation has been given which we need to select that. So let's take an as already discussed that the boundary nodes has not satisfied these eight neighbors. Let's take as in one example that is, and let's take the boundary. We are drawing here the boundary case. Okay, so this one, and this one. Okay, so here, yeah. So this is an read like this, and we are suppose evaluating for this no this cell. This is one node. We can say that, and let's see how many neighbors for this red node. Red node. You can see here. This is an first node. One, two, three, four, and five. Only the five neighboring nodes will be possible for the boundary nodes. So it's not satisfied that the condition has been given, which is an exactly equal to eight neighbors has been given, right? So here is not possible. Also there is another condition which is an that corner node is also not satisfied. That means corner nodes also the road nodes, this will be we have applied for the column case, this will be applied for the last row and first row also, right? And as well the corners also. So you can see we have a final grid. In that final grid, this boundary, so let's take an this boundary cells has are not satisfied the, so these boundary cells are not satisfied the this condition, right? Only in between these grids means these grids has been satisfied the condition. So how we can get these grids? So now you can see that the blue one, the blue boundary might be you might be understood how we can calculate. Blue one is an 120 into 90. Okay, let's uh, let's write it again. 120 into 90. Okay, after removing uh, two rows and two columns. Why two? Because why two columns we have removed? Because this column is the first column and the second last column also. So these columns we have to remove. Also, we have to remove the first row and the second row. The two rows we need to minus it, and two columns we need to minus it. And then we, other than this uh, um, boundary nodes, all the internal nodes, these are the internal nodes, right? These are the internal nodes has been satisfied, the condition has been given, which is and those nodes has exactly equal to eight neighbors. Understood, right? So so how, what is the correct answer here? So let's 120 minus 2, okay, into 90 minus 2. So 120 minus 2, how many, how much you will get? 1 8 118 into 88. So that the correct answer is and third one. Understood? Yeah, I hope you guys understood the question and solution as well. Is there any doubt or difficult to understand anything? I will repeat those concepts as well. Yes, anyone? If not, let's move to the next question. I hope you understood the concept has been taught in the lectures in this week, which is about the spatial segregation. Using the scaling method, we have discussed, we have implemented the how we can segregate the similar type of the nodes, and another concept which is an positive negative structural balance, stable or not stable, how we can evaluate it, how we can mm, uh, how we can unstable network we can stable it the network. That implementation we have also discussed in this. Let's move to the next question. Identify the statement that is correct. The first statement is that structural balance involves studying the interplay of positive and negative relationships among the nodes. Uh, First, you please take a time and please read these options. What do you think, guys? Which option, which statement is incorrect? Take a time and read these options, four statement carefully. Let me know which one is the correct and why is that. Is there any wrong answer? Please don't hesitate to give the answers. Okay. Anyone? Okay. So okay, I will read. We are now at question 4. Yeah. So in this question, mm, we need to find out which statement is and incorrect. So I will read the statement. With the first statement is that structural balance involves studying the interplay of positive and negative relationships among the nodes over the time, right? So this option, it's not saying the concept, how the concept is, and I mean how the unstable structure has been converted to the structure. It's not saying that only, overall giving one statement which is, and we are playing with the positive relationships and the negative relationships, right? And those positive relationships and negative over the period of time, it's and changing, right? So we are playing with those ages. So the first option is seems correct, right? The second option, which says that structural balance is a theory that offers ways of equating the number of positive and negative edges in a network so that it becomes a balance. So the second statement is saying that we have that structural balance is a theory which says that, which returns that, uh, the number of positive edges exactly equal to the number of negative edges. So this is not we are doing in the structural balance, right? In the concept of the structural balance, we are finding the triadic structure which is in balance or not balance based on his positive and negative relationship. And there is no as such cases. It's a number of positive edges and negative edges we are checking and evaluating or uh, verifying that is an exactly correct, exactly equal to or not, right? It's not equate, we are not equating the number of the positive and negative edges over there, right? We are only considering how many positive edges are there, how many negative edges are there. Suppose there is and only two positive edges are there and one negative edge is there. So in this case, in this triadic structure, in this case we are calling as in that structure, that triadic network is an unstable, right? If there is an two negative edges, which is an two negative edges, and there is an positive edges, that already example we have considered, that two employees and common boss, right? And they are talking about those that bullying boss, right? And there has been strong friendship has been made over those employees. These are the employees, right? Those are employees. So this is an balanced structure, right? Or the concept we have, real life example we have considered. So this option seems it's not correct. It's incorrect, right? It's not, we are not equating the number of positive and negative edges over the network, right? To make a network is unbalanced. For the balanced, we are find means in the balanced there is another concept actually, that uh, what we can in the spatial segregation. In that we are doing that, it is unbalanced or not balanced. Here we are checking and stable or not stable. Also we have found that that is and two groups are there. There is a positive connection in between these groups, and here is also in this is an A group, this is an B group, and here is an multiple nodes are there, multiple nodes are there, and in between those nodes there is an positive edges, and over these groups, among this group there is an negative edges are there, negative edges are there. Okay. So this is the theory we have discussed in the structural and structural balance, stable and stable properties, right? The third option is that structural balance illustrates nice connection between the local and global network properties, right? So uh, we are currently implementing this local properties, right? Local means if there is an unstable, then we are converting it into the um, stable network, right? So while converting the local network, triadic network, there is a whole network visualized as a structural balance network. So it interrelates to the local and global properties of the network. The last option, which is an structural balance, is to understand the tension in between the two forces, the friendship and antonym. So this is an that is an enmity, that is a negative edge and positive edge. So right, we are finding the tension is given one reference name, which is and how much the two users has an how the relationship is, means it is a friendship relationship and it is an antagonism, that is an enmity relationship in between those users. So these options are correct, right? It isn't, it shows in global local properties, and also we are interplaying or understanding the relationship between the users using the, that is in friendship and antagonism. Yeah, I hope so. Here the option is an incorrect only, that is an second option, which is an equating the number of positive and negative. It is not correct, right? I hope you understood this the theory. Let's move to the question 5. Given a triangular network with the two negative relationships, when is the network stable? So what the next, let's draw in the network properties. So we have a node and two edges are there, and it has been given that two ages, two relationships, right? Two relationship is a negative, so negative relationship. If let's take let's take this one is also negative. So they are saying that, so only considering these properties, this condition, which is in two ages as a mean negative. So every time the network is in balanced or not, mean stable or not stable. What do you think, Manish? Yes. So only consider this property. What would we conclude that every time or sometimes the network is a stable or not stable? Let's take and let's draw. No, let's take a different scenario considering this condition. Okay. So suppose we have added as an positive age here. So in this case, the network isn't stable. Right? So we have considered that example, which is an uh, two employees has a common boss which has been bullying to them. So here that is an his boss and these are the employee. That is an enemy relationships are there, and in between the employees there is a positive relation. So this is balanced. There is no issue. Let's take another condition. Let's take this age which is an negative. This should not be possible, right? After some period of time it makes as an positive age, right? This should not be, there is a not enemy uh, in between the tribes, right? So the already concept has been illustrated, which is an enemies of enemies, enemies of friends of enemy is an friend, right? Enemy of enemy is a friend, right? Like that. So considering or considering this scenario, this statement, this is not possible. So in this case, that is an unstable. The network is unstable. So that this condition, it's not always it's stable, right? It is not always stable. Also, it is not never stable. It sometimes it's stable because sometimes suppose there is a positive age in between these users, then this network is a balanced network, right? Balanced network. So the option here, option 2 is correct. Sometimes it is an stable network. It's not always or never, right? Yeah. Okay, this question you can. This is a simple question that we have many times has revised the how the network is unstable and which cases is a network stable is and not which cases a network is unstable. Right? We have discussed that. So considering that, please look into this question. Please let me know which option and which answer is correct. Sorry, there was an convenience. There is an connection trouble. Yeah. So, is there any answer for this question, or should I move ahead? Look at this video. Look at this network. The reason two networks has been given. Okay. Yes. Anyone? Yeah. Okay. Uh, so let's dig into this question. Which of the following is complete graph? Which of the following complete graphs are structurally balanced? This is so has been given two graphs which are the complete graphs, the graph A and graph B. So you can see the structurally it looks similar, but you can see the edges, the relationship between those users are different actually. So the relationship between those users has been different. So you can see here that between the relationship between the A and C in option A, which is a negative relationship, which is an anonymity relationship. Sorry, enemy uh, relationship has been given, right? And in option B, there is a relationship has been given which is a friendship relationship. Positive shows friendship relationship, negative shows and enemy relationship. Okay. So the considering mm, this network, that network A and network B, which is a complete graph, what do you guys think that which graph is and structurally stable or balanced graph? Right. So we have let's draw, means I will draw here the stable connections. It's, how many stables means two cases are there in the triadic structure, right? Suppose there is an positive positive, there is an in between the three people there is an friendship in between them, then there is an stable network. We can say this is an stable network. If there is an if there is an suppose let's take an two, there is an two negative edges and there is an positive edges are there, then this network we are calling as an um, which is an structurally in balance also, right? So here this is no problem because all the friends are all the users are the friends each other, there is a no issue in between them, they are long time sustained each other, right? But here you can see the concept we have discussed as earlier, which is an there is an common boss which is usually bullying their employees, right? So here you can see that this is an a boss which is bullying to these employees. So he's a bullying, that is a negative edge. It is an enemy of this employee, right? So it is a negative edge you can see here, right? And so these employees, they are initially they are not friend each other, there is no relationship between them, but after some period of time they are talking about his common enemy, which is an his or her uh, uh, common bully boss. So they are discussing or talking about he, his behavior, and so after some, because of that reason there is a in between the relationship between those users is making as an positive relationship, as a good friendship they are there has been made in between them, right? So this is a stable network as we have. Apart from this network, those are the unstable networks. So please analyze that. Considering these two stable networks, which network in option A and option B in the complete graph, which graph is an structurally balanced or a structurally stable network? I hope you understood these two cases, which has been already covered in the uh, lectures, and also I have covered in the initial starting session of this concept. So, what do you think that which option is correct, or which network is then structurally balanced or stable? Okay, let's analyze. Let's go by the reverse. Option B, Manish. Let's see the option B is an structural balanced or structural. So the stable and structural balance is a similar kind. Yeah, let's see option B what is happening. Let's move to the first option A. Okay, there might be two options are correct or balanced. So let's take one by one triangles, right? So we have to analyze the triadic structure firstly, each smaller triadic. Then each triadic structure is an structurally stable. Then we can say that overall network is an structurally balanced. Okay. So here, let's take this triangle, right? So here the two nodes, two edges are the negative and one edge is in positive. That is an that already uh, explained here, right? Right. The two edges has a negative edges, which is an common boss is there, and the employees in between the employees there is a positive relationship is there. So this is a structural balance. This network. Let's consider the let's see the another triangle which is an this triangle, right? Which is an ABD. You can see here the two edges as well. All the two edges has the positive negative and one edge is in positive. This is also fine. This is also structurally correct. Another exam, another triangle. So the three triangles have been possible here. So let's see the another triangle. Here is also the structural balance, right? The two negative edges are there and one of the edges and positive edges. So this overall network is an structurally balanced network, right? Let's move to the option B, which is an another graph. The same structure is there, but you can see the relationship is are the different, which is in positive negative signs are the different here. So let's take this option. So this triangle, you can see here there are two positive edges are there, one negative edges are there. So this is not possible, right? This is not possible, right? Already given the one example, which is an let's say I will repeat that example again here, which is an let's take an one uncle is there, one aunt is there, right? And some students have joined lately, so I have uh, uh, I will explain it again. So here, so this is an uncle node, and this is an aunt node is there, and this is an one boy is there. Okay, right. These three nodes are there: uncle, aunt, and boy. Right, boy means is one maybe relative is there, right? And there is an there is a positive relationship between the uncle and boy. There is a positive relation, there is a good healthy relationship in between them. But there is a uh, not healthy, that is an it's a negative, and they are not talking to each other, uncle and aunt. There is an uh, negative age in between the uncle and aunt. Let's take a real life scenario which says it is an stable or not stable. This relation means this relationship stays long time or not, that we are discussing here. Right? So let's take a one scenario. Uncle is saying in this Saturday, in this coming Saturday, can we go in? Can we go party and let's have an enjoy? Uncle is saying to boy, and uncle has given a condition. You can come with me. We will go together for the party, but there is one condition: you can't take an aunt with us. Right? This has been condition has given to the boy. So this is one scenario, right? This is one condition has been given the uncle. So another condition has been given from the aunt also. She is saying that yeah, the boy has a name. Let's take as an I don't know. Let's take an the Punit maybe. So the Puneet is here. That's why I have taken the name from here. Okay. So the auntie is saying to the Puneet, yeah, in this Saturday, let's go to the Kedarnath or any temple and let's visit the that place and let's have an uh, let's take an prasad and all the things, right? And she has also taken a one condition, given a one condition, which is that uh, we can go together, but don't include the uncle in this journey. So the Puneet is confused. What should I do? Right? He is not going with the uncle also, if he's going with the uncle, then aunt is very mm, rude with us, means the relationship the positive relationship not will be consist, right? It will make a negative relationship over the period of time with the aunt, right? And opposite also, right? So the boy is not handling this two positive relationship at a time. So this condition, this static relationship, it's not stable, right? After over the period of time, the relationships has been made, this may be converted as in positive, then this relationship will be consistent or will be healthy relationships that we are saying, right? So that's why this relationship, this static relationship is not stable, right? Also, let's take as an uh, another triangle which is an ABD. This one, this is also, you can say, this is negative, negative, and positive. Which is an, let's recall that example, which is an that two employee has a common boss, right? Uh, that bully boss, he's bullying to the employees, and employee has a positive relationship in between them, right? So this is structurally balanced, stable. Right? You can take this example. This also has an two positive and one negative, which is an, let's take this example. Considering this, the uncle and aunt, and the one another boy node is there, and there is a two really positive relation. There is one negative relation. This is also not stable. So overall, this network is not balanced, right? So only A option, that A structure, this is an only the balance. So which of the following complete graph is structurally balanced? Only A, right? I hope you guys understood, right? Let me know, is there any doubts or any confusion in that? I will recall that. Okay, let's move to the question, another question, which is an, given a relationship between three people, positive, positive, negative. Let's draw, while reading, let's draw, visualize the question, how it is saying that. Randomly, I'm placing the positive, positive, and negative relationship. So the three peoples has given there, A, B, C. These are three people or three users, we can say that. And there is a positive, positive, negative relationship has been given. Where positive represents the friendship relationship, negative represents enmity relationship. Right. So here you can see A and B has a friendship relationship. A and B, A and C, that is an also friendship relationship. C and B, there is an enmity relationship. There is, and they are not talking to each other. They are not seeing to each other, right? So this is the condition they have given. Considering this scenario, which of the following options is or are valid options to become a stable network? So we understood, we know that this is an unstable network. Like, suppose we want to convert this unstable network to the stable network, we have to make some changes in this or some modification in this network. So which modification we need to do? Let's see the options are there. The first option, which is an one friendship transforms to the enmity. One friendship means one positive, any of the positive relationship transforms to the or converted to the negative or enmity relationship, which means they are saying that option one is that is an one friendship has made negative and another is an, so this option is an correct. This network is a stable network. After doing this modification, the network shows any positive, means stable network, stable condition, right? Also there is also an option is that you can make this condition also negative, it's another edge as an enmity, so this is also stable, right? So this one is an correct, we can implement this option for the modification to make a network stable. Another option is that one enmity becomes a friendship, means they are saying that this option, so enmity, there is only one enmity is there, right? The positive, positive, and positive. This positive has been converted to negative, has been converted to positive. That means also this is also fine, right? Among the three of the users, there is a positive friendship are there, so that is a healthy relationship, that is a stable network, right? So this is also fine. Both the relation, though both the friendship turns to the enmity, this is not true actually, right? The three of the ages, which is an negative, this is not, this condition not, or this situation or this network not shows an stable properties, right? In this case the network is unstable, cannot become unstable. This is not, it is unstable by implementing this modification. So option 1 and 2 isn't correct for the modification to make a network stable for this condition. Yes, is there any doubt in this? Okay. Yeah. So then the next question, let's see the concept of the spatial segregation. So we have seen that in this week lecture, which is an spatial segregation we implemented using the scaling method. Right? So let's recall that concept for this question. Let's see how the question is saying. What is the question is saying? Consider the Frank McCown simulation of the scaling model illustrated in the course. The simulation has parameters, right? The parameters are there, means the similar threshold, how many neighboring nodes are the similar types, right? If they are similar types, then he will not remove, or he will not shift to another location, right? If there is a no no, there is no at most similar, means there is no as such similar neighbors are there for the central node, then in that case the central node will be shift or migrate to the another. Here you can see here that this is an, let's take here an example. So there is a central node is this, and there is an four neighboring positions are there. It, right, 1 2 3 4 5 6 7, right? So let's take and this one, no, this one, other than this one. So how we are, I'm just recalling the concept actually here, how the scaling method is, or how the spatial segregation is and evaluating, right, for the similarity evaluation, right? So here what we are doing, we are evaluating the central node. Central node will be shift or not, he will be shifted to another position or not. When he will shift, uh, before that it will check that, it will evaluate that for the central node how many neighboring nodes are there. There is a total 8 neighbors are there, you can see 1 2 3 4 5 6 7 8, right? Out of 8, how many he has a similar type of nodes? So you can see the similar type of nodes, there is 1 2 3 4, four similar types of node, that is a threshold, we can see that. And that is an hyperparameter actually, how we are, if we want t is equal to 3, then we are checking, in this case this condition is unsatisfied. In this case the central node not be shifted to another location. So now the condition has been satisfied if it is an t is equal to 5. So in this case the condition is an false, right? So in that case it will be shifted to the another position. In that case their neighboring has an at most I know greater than the 5 neighbors. So this is one concept about the scaling model for the spatial segregation. As similar increases means threshold, whatever threshold we are putting, as threshold increases, it takes more time for the system to stabilize, right? This is an true maybe, right? Means more the number, more the threshold you are adding it, more the shift it will be do, it will be made actually. The system will always stabilize no matter what the parameters are. Is it true? The system will always stabilize. Let's keep aside and let's move to the another question, another option, which is an the third option. The system can stabilize even if similar 100%. Yeah, this may be possible if there is an large number of empty cells are there. Means when this where at which position this central node will be shifted, right? Where there is an empty spaces is also there in the grid, at that position this nodes has been shifted. If there is a lot, means many empty space are there, this can be done. That is a third option. The 100% similar means t is equal to 1. All the nodes, whatever the nodes are there, all the nodes are with similar, this condition will be can be done, right? In option 4, spatial segregation doesn't always induce communities or clustering in the grid. I think this thing has been already covered in the lecture, which is, and means it's not uh, after segregating the overall nodes, it means similar types of the users are staying in together, right? Let's take and one example might be that will be easy to understand. Let's take suppose the t is equal to 3. Okay, t is equal to 3. Considering this, let's take this example. So this one is unsatisfied, then this one, this one, this one, this one, right? Maybe, right? You can see this is not how the communities look like. Community look like there is an only this type of nodes are aside, and this another node type is, and it's and make as an their whole network is different, right? This is an community or clustering structure look like, right? But here you can see that t is equal to 3. This node has satisfied the neighboring is equal to 3, right? You can see each node, this one node satisfied with the 3 neighboring nodes. So they are satisfied the stable connection, means they are satisfied the similar types neighboring nodes. So considering this, so it's not shows that overall network not shows that it is an um, a resultant network is, and resultant grid network is and clustered network. And see here, this is not smaller clusters has been made here. So uh, this option is correct because it doesn't always, it's not always shows and clustering, might be sometimes shows the cluster communities, and in these cases likewise it's not shows and clustering properties, right? Yeah, so the option here, the option 2 is incorrect. The system will always stabilize no matter what is the parameter, because let's take suppose there is an empty cells grid. In the grid the empty cells is in very low, or there is no empty cells are there. There is a difficulty to shift or difficulty to migrate that particular node to the another position, right? uh, okay, I hope you guys understood this concept and question, and let me know any doubts or any queries about this question. Yeah. Let's move to the another question. Which of the following statement are true for structural balance? The first statement is that for every set of 3 nodes, exactly one of them is labeled positive. Right? For every set of 3 nodes, exactly one of them means, let's draw here the 3 nodes are there, and in 3 set of nodes, exactly one of them is an positive labeled, right? So this is an positive labeled structural balance, right? For every set of 3 nodes, set of 3 nodes, if all 3 of them edges are the positive. So the statement 1 says this and statement 2 says this. There is an 3 nodes are there, in between the edges, in between the three nodes there is a positive relationship. So this shows an structural balance, right? And here uh, there is an only single exactly one positive relationship, then the other might be negative negotiations are possible, right? So in this case also the network is unstable, right? So option is in 2, both the statement is correct. I hope you guys understood. The last question, assume there are 100 people in the community who know each other, pick out all the scenarios when the community network is stable. Take a time, please look into this question and let me know what is the correct answer actually. What do you think? Which option is correct? I will read the first option, which is then 75 people are friends with each other. 25 friends are they are 25 people are friends with each other, and there is a negative relationship in between the two groups. Let's draw this scenario actually to help to understand the first scenario. So the first this one. So there is an 75 people. Let's assume this is an 75 student peoples are there, and in this there is an 25 peoples are there, and in between there is an positive relationships are there, right? Positive relationships are there, and it says that this there is an two groups are there, right? And among these two groups there is a negative edges are there. Only negative edges are among these groups, not in between the group, in the group, right? Right. So this scenario, we have seen that in this scenario the network is unbalanced, right? I think this already the concept already covered in the lecture as well. Yeah, this is an true, right? This is a multiple selective question actually. The multiple options are correct. So this is a stable network, as already said that. Another thing is all people are friends with each other. All people means there is an 100 people are there, and in between the 100 people there is a friendship relationship there. So in this case there is a no issue, right? There is a positive relationship in between them. So this is an healthy relationship. Right? This is also stable, as we have already talked. That is an in product nature and network. All the edges as in positive edges, which is a stable network. Right. Likewise, the third option, which is then 30 peoples are friends among each other, and 40 are friends with uh, each other. And another, there is a three groups you can see here. The 30 are friends with each other, and there is an antagonism, which is an enmity, which is a negative relationship between each group. Let's see here, which is in three groups. The first group, third group, and this is in 30 people are there, 20 people are there, and 30 people are there. Right. So here in between there is an positive relationship. In this also positive relationship, and in between among these groups there is an negative edges are there. But as we have seen that there is a no in real life example, there is a no as such three groups are formed, right? There is an in some time they will make together and they will fight to the third group, right? Likewise, the already Dr. Sudarshan has been given the example, right? There is only two groups had been made in the war as well, right? The country example has been given, right? Suppose the war has been continued in between the two countries, then suppose the third country is participating in the war, then that country will be participate to one of the group, right? One of the country, and then there is an war in between the two groups, right? Instead of the third. So this is not true for to make a stable network, right? Another example, which another last one is an there is an antagonism medist set A of 75 people, and antagonism medist of set of B, say 25 people, and friendship in between there. This is an this statement has an opposite of this first option actually. So he's saying that the last option is saying that there is an two groups are there, and in the first group there is an negative relationship in between this group, and also the negative relationship in between the another group, and there is a positive relationship in between among this the groups actually. So this is not it not shows an what we can say the stable network actually. We can draw here as well, means let's take two nodes. Here is one node, let's draw here, right? And this is a negative and this is a positive relationship. right? As we can say, in the among the group there is a positive relationship. You can see here, it this triangle look should shows and stable properties here, right? Among the group there is a negative relation. Also, let's take another example. So you can made here as in positive, and you can made a negative relationship here. This also shows a positive relationship overall the network, right? It shows a stable network. Yeah. So here the options are uh, the two options are correct here, the first and second options. I hope you guys understood. Is there any doubts? If you are not understood any concepts, please let me know. I will recall that in a few minutes.